Here we have lesson 2.1. Lesson 2.1 key questions are: what do forces do to things, and what if more than one force acts on something? To help us understand what forces do to things, we're going to consider a tug of war. A virtual tug of war, I guess you would say. In this scenario, we've got little Bobby Blue pulling on a rope. The rope is attached to a cart. A force is just that. It is a pull on something. A pull or a push on something. And it can be represented, as we have here above the cart, by an arrow. The arrow is given a name. We call it in physics a vector. And here the vector is pointing to the left because that's the direction that the force is being applied. The size of the arrow is such to represent that the force may be sort of small. If we add Bobby's sister here, Billy Joe, we can see that the force vector in fact gets larger. And we can see that it stays in the same direction. If I add a couple of members to the red team, namely little Ralphie and Raylan Red, we can see that the net force is 0. There's just as much force to the left as there is to the right, and so the forces cancel. The sum of the forces is 0. If I allow these two blue kids here to pull against the two red kids, nothing's going to happen. The net force is 0. And we have what's called static equilibrium. Take a break, kids. Take a break. Thank you. If I add people, the force increases. In fact, let's click this here and just see how much force we're dealing with. It says here 200 N to the left and 200 N to the right. So the forces here are equal, and if we let them pull against each other, the cart does not move. Static equilibrium means that there's just as much force on the left as there is on the right, and that it's stationary. That's what static means. It means stationary. So there's no movement here. Take a break, people. Take a break. Okay, there's no need to hurt yourselves. As long as we have the forces equal on both sides, there's no motion in that cart. We can't get it started. Only if we have an advantage on one side over the other can we get the cart to move. And here I've added the big bopper. Now, the net force, as you can see by looking at the green arrow up above there, is 150 N. N stands for newtons, so it's a unit that we measure force in. So 150 newtons of force is the net force acting on this cart. And now when we set things into motion, we see that the blue team does in fact win. Well done, blue team. Well done. You should be able to look at things and be able to determine whether or not the net force on something is 0. For instance, in this case, the net force is 0. There. The sum of the forces equals 0. And as you saw, the cart does not move when we allow these people to push. Alright, take a break, take a break. I should say pull. When they pull against each other, the cart doesn't move. So a net force means that we have static equilibrium. A net force of 0 means we have a static equilibrium and the cart does not move. I want to take a look at one other scenario here. Let's take Ralphie out of the mix here and let's set this thing into motion. You can see that the net force now is 50 newtons, and so if we let little Bobby pull here, Sure enough, the cart starts to move. Let's freeze it. And let's add, no, let's not add Ralphie. Let's add his mother, Ricky Lee. Ricky Lee Red now joins in the pulling. We're going to set time back into motion here, and let's see what happens. Alright, so the cart slows down, stops, starts to change direction, and Ricky Lee is pulling it more towards the red side. Well, let's give little Bobby some help. His mom, Bertha Sue, steps in, and look at what happens to the net force. Let's see what happens here. So the cart continues moving to the right initially, slows, and begins moving to the left. Freeze. We're going to add in Ralph Red, Raylan Red, and there's little Ralphie. Let's add the entire red family, and let's see what happens. The cart slows, starts moving to the right. Now, the cart was moving ever so slightly to the right, and I freezed this picture. I'm going to add the members of the blue team. Now, what's the net force? The net force is 0. You can see up on the top. It's no mystery. It says right there, the sum of the forces equals 0. But what's going to happen? Will the cart be stopped? Remember, I'm freezing time right now, so it looks stopped, but of course time is frozen. When I get time moving again, will the cart stop because the forces are balanced? Will it continue moving to the right, or will it start going to the left? Let's find out. We see that the red team wins. Now, that's an interesting thing to take a look at. Previously, when I had both teams pull against each other, we had static equilibrium. In other words, the cart didn't move. The forces on the left equaled the forces on the right. But in the case you just saw, where there was some motion going to the right, I had a net force of 0. It should have been in equilibrium. And yet the cart kept moving. How it moved is important to note. It moved with a constant speed. And things that move at a constant speed don't have a net force acting on them. And so we have a different name for that. That's called dynamic equilibrium. So, net forces, static equilibrium, dynamic equilibrium, and vectors are all talked about in this lesson. You need to know those terms and be able to use them. Until next time, bye-bye.